Hello Algebra 2B and welcome to Lesson 8.4. Today we are going to be adding and subtracting rational expressions. The key thing for today is that we need to have common denominators. And that is just something we always needed whenever you add or subtract fractions. Denominators. Okay? If there are common denominators, that makes your life a little easier. So for our first example, these are both 6n plus 12. What that means is we can just add together the numerator parts right off the bat. So like terms would be 5n and n, which would be 6n. Negative 6 minus 2 is minus 8. And when you add fractions, the denominator stays the same. You don't change it. It would not be 12n plus 24. It's just 6n plus 12. Now do simplify, okay, or reduce. And you can do that if they all share a common factor. So all of the numbers, 6, 8, 6, and 12, they all share a factor of 2. So I can reduce all of those by 2. And what that would then be is just, so 6 divided by 2 is 3n minus 4 all over 3n plus 6. And that would be your final answer. So again, you cannot, so don't cancel out the 3's. You can't do that with the n's. You can't do that because they are in quantities, so to speak. Okay, so that is your final answer, reduced. If you can get to this point, that's fantastic. But if you can reduce it, even better. So number 2, we have the same denominators, so that makes us happy here. In that case, that means all we have to do is add the like terms. So 3m and m is 4m. Negative 1 plus negative 6 is negative 7. And then we can just leave that over our denominator, 4m squared minus 4m. Check to see if anything reduces. They all have to have a common factor. So this 7m is kind of throwing things off as it does not have an m. It does not have a 4. So really, that is your final answer. A pretty easy one there for us. Subtraction is just a little trickier, okay? Here is where it's important to recognize these are in parentheses as quantities. Common denominators, so that's nice for us. We'll just represent it as 8a plus 4. What I would recommend doing is, so we have our first bunch, the a plus 6, distribute the negative. Alright, that's the only trick with subtraction. So it's going to be minus a plus 1, and you can actually get rid of those parentheses from there. And then you can add your like terms. So make sure you distribute with subtraction, okay? From here then, add like terms, a minus a, those cancel. 6 plus 1 is 7, so 7 over 8a plus 4 doesn't reduce anymore. That is just the final answer, okay? So we're going to need to distribute. So same denominators, so that makes us happy. 4n squared minus 20n. Over that, really, there's nothing to distribute to, so I'm just going to change it to addition and distribute that there. From there then, n doesn't have anything else to add to. 3 minus 2 is plus 1, and there's nothing that can reduce, so I'll just leave it like that there. Okay, so subtraction, just remember to distribute. Now those we already had common denominators. Where it gets tricky is for things like 5, where there are not common denominators. Oh no. Okay, but it's an easy fix. We just need to make the denominators the same. Okay, and it's really not too bad. So I'll highlight this here. So for the first fraction, we have this as a 2x. And the second fraction, we have this as a 3. Okay, the easiest way to multiply in order to make common denominators is I'm going to multiply this first fraction by the 3, So I'm going to multiply by 3 over 3, okay, to the first fraction. So 5x all over 2x, plus, and I'll multiply the second fraction by the 2x, 2x over 2x, and it's a 3y over 3. And what that will do is just, you'll see, it'll make common denominators. So the first fraction is then 15x, 3 times 5x, all over 6x, okay, plus 2x times 3y is 6xy, all over 6x. Don't reduce at this point. Instead, we're then going to add like terms. So 5x plus 6xy, 15x, sorry, all over 6x. And from here, if they all share something, so now see, what do they all share? Well, they all share an x, okay, and they all share a factor of 3. So I can reduce everything by an x and a 3. So think of it as 15x over 6x, okay, reducing by 3 would be 5, and the x, plus 2y all over 2. Okay, so they all share an x and a 3, and again, this first step's great. If you can catch everything that they share and reduce that out, you can do that there. Okay, so they all reduce by x and by 3. The trickiest part, again, is getting the common denominators. The next example, so we are going to have to make common denominators again. So let's highlight everything that the left fraction has. It has a 6, it has an x. Okay, the right fraction has a 2, it has an x squared, and a y. Okay, so a few different options here. You could just multiply the first fraction by everything in that denominator. Okay, since this already has one x and this has an x squared, really you only need to multiply by a simple instance of x. But let's just multiply the whole fraction, 2x squared y over 2x squared y times the first fraction, minus, okay, 6x over 6x, and then 6x all over 2x squared y. So again, second fraction is just a switcheroo of what we're multiplying by. Distributing the top is 4x to the third y minus 36x squared all over, and you should get the same thing, 12x to the third y and 12x to the third y. So from here now, see what all is being shared. So 4, 36, and 12, they all have a factor of 4. So we can reduce by a factor of 4. They also all have x squared involved and an x squared. So I just write that as a little note to itself. So if I reduce 4x to the third by 4 and x squared, I'm just left with xy. If I reduce 36 by 4, that gives me 9. X squared is reduced, and the denominator by 4 is 3xy. And that is the most reduced that one can be. Again, first step is great. Second step is even better if you can reduce everything. Okay, last examples, I believe so. These ones, so just recognize, so the left fraction is missing Now really, if you want to be fancy, so this is a 6, that's a 3, we can just multiply the first one by a 2x. And the second one, and I'll write this down here. The second one, in order to make a 6, we can multiply it. We don't have to multiply it by anything, actually. It does need a y, however, so I can multiply by y over y, and then 2x over 6x. And notice what that gives us is 6x all over 6xy minus 2xy all over 6xy. So long as these denominators are the same, you're okay. But certainly, if that was too much for you, you could also just have multiplied by 6x over 6x. And 3y over 3y. X over 6x. Okay. From here, adding, subtracting like terms. Okay, these are not like terms, so they can't combine. It's a little bit of a mess. 6x minus 2xy all over 6xy. Everything has a factor, so we can reduce by 2 and an x. So as we reduce by 2 and x, what that leaves us with is 3 minus y all over 3 and y. Okay, so that is reduced for those values there. Next one, so let's just do it old school style. First fraction's missing a 4, so I'll give it a 4 over 4. And multiplied by 5x over 2x to the third. Second fraction, so we're adding, is missing 2x to the third. So 2x to the third, 2x to the third, over 4x over 4. First fraction is then 20x, all over 8x to the third. Second fraction is 8x to the fourth, over 8x to the third. These are the same, so we're in good shape. 20, so I'll write it in proper form, x to the fourth plus 20x all over 8x to the third. And what does everything share that we can reduce by? They all share a 4, and they all share an x. So I'll reduce 8 by 4, which is 2, and an x, x to the third, plus 5, all over 2x squared. That is reduced. So finally started to get a little more challenging. I like to think multiplication, division were easier. So try out the practice problems for sure. Recognize you need to change some denominators. If you have common denominators, you're good to go. So nice job, guys. Keep it up.